Hey guys, you're back with Mr. C for another math video. This is the Geometry Quiz DLM-043, and I'm going to help you with the formatting of the test. Not so much with the answers. You'll get the answers, but that's not the point. The point is being able to understand how to take the test. So, first thing I want you to notice is whenever you have three letters together, that will always be an angle, because the first letter is the first point. The second letter, the one in the middle, will always be the vertex, and the third one will always be the last point. Let's take a look at y, x, d. So y is here. We go to x here. That's the vertex, where the line changes direction. And you have d. And what you do now is you ignore everything else. Everything. Ignore this line together here. This doesn't exist. Doesn't exist, doesn't exist. Everything else goes away. We just have y and x and d. Well, this yxd forms an angle. You can see it forms an angle. Well, that would be an acute angle. It's less than 90 degrees. So yxd is an acute angle. Number two, we know it's another angle because we have three letters. We know the middle one is the vertex. So it's going to be some type of angle. We're going to describe it as some type of angle. We have M here, we have C here, and we have W here. Well, what type of angle is when it has a very straight line here? That's what we call a straight angle. So a straight angle has no degrees at all. It's just simply straight across 180 degrees. There's the vertex. So MCW is an angle that's called a straight angle. And number three. Now these are not together. They have commas between them, so it's going to be three separate things. They say items H and C and Z are what would you call them? Best described as which of these? So I look at H is there by itself. And then C is over here, again not connected. And they have Z. And Z is over here. So for this one, you don't like connect them with your imagination. They're all separate. They just want to know what is H, what is C, and what is Z. Those are all points. H is a point, C is a point, and Z is a point. And you may argue, well, C is also an intersection or a perpendicular line. That's true, but they're saying not just C, they're saying what is Z and what is H, and all those three things would be called points. There's no other angle that there's no other answer that makes sense there. Number four. Come on. Number four. Okay, so we know that C do not have three letters. They must be just either rays or lines or line segments. So let's take a look at D to Z. So D to Z, ignore the X there. Just D to Z is one thing. And RK. RK, R to K is another second thing. So they're saying, what would you call these two things? Well, they're different because this D to Z is a ray and R to K is a line segment. So are they perpendicular to each other? No. Are they both rays? No. Are they parallel? Yes, they are parallel. And are they obtuse? No. So the answer was parallel. DZ is parallel to RK. Number five. We know it's an angle because it has three letters, H, R, C. One point, the vertex in the middle, and you have the last point. Let's find H, R, C. So H is there, R is the vertex, and C is over here. So that forms an angle that we ignore everything else, and that's going to be an obtuse angle. And again, you ignore everything else. Number six, TW. That's not an angle. Let's find TW. So T there, and W is there. They're just saying, just look at this point here, and just look at this point here, and then connect those two, and what do you have? You have a ray. And you may say, well, what about this little angle here, this little arrow here? Should I focus on that or not? Well, no, because that was part of this line here. you ignore that? You just have the W by itself. You just have the T, and at that T it has a symbol for going on forever. So TW is a ray. It starts here at W, goes in that direction forever. That's a ray. We know that number 7 is another angle because it has 3 letters in it, and the C, the center point, is the vertex. Let's find M, C, and Y. So M is here, C is here, that's the vertex, and Y is way over here. There's the Y. And again, you ignore everything else and just focus on the Y, the C, and the M, and I see, in my imagination here, we just connected just those 3, I would see a right angle. A right angle. Alright, now names of shapes. A and E. A is a triangle, E is a triangle. And I noticed then that both of them have one side that's longer, and then the other 2 sides of both of these triangles have the same length. This one here, and this one here, same length, and same length, and the same length. Those are called isosceles triangles. Isosceles triangles have 2 sides that are the same and then 1 side different. Number 9, items J and F. So J is here, F is here. I know that these 2 are both going to be trapezoid because trapezoids have one side that's parallel to each other, opposite sides parallel, and the other 2 opposite sides are not parallel. So opposite side here is parallel to this, but then the other 2 sides, the opposite sides, are not parallel. So there's a trapezoid and there's a trapezoid. These are 2 trapezoids. Number 10, items L and D. So let's find L. L is here, D is there. So L and D are the names you used to call diamonds back when you were a little kid, and now we call them rhombuses, and here's why. A rhombus is a 4-sided shape where all 4 sides have the same length, but that their angles are not 90 degrees. So if all 4 sides were the same, like a square, and they were right angles, then it would be a square. But they're not. Think of like a rhombus, like a squished square, like a flattened square. So those are rhombuses. L and D are both rhombuses. 11. What is item K? That's easy. Item K is a triangle. And a triangle where it has a long side, a medium length side, and a short side. That's called a scalene triangle. Item 12, this B, looking for B. Oh, B. B is here. B has one set of parallel lines here. They're opposite. They're the same length as each other. And it has an opposite other side that are also parallel to each other and the same length. When you have something like this, it's called a parallelogram. Parallelograms are opposite sides the same, and opposite sides are differing lengths but the same matching length. And that's why a parallelogram, that's why a rectangle is also a parallelogram, because you can see that these share the same thing. They have opposite sides that are the same length. They're parallel to each other. And it has shorter sides here, but they're also parallel. And the only difference between a parallelogram and a rectangle is a rectangle has 4 right angles in it, and a parallelogram does not. So think of like a parallelogram as a kind of a squished rectangle. These are both parallelograms. This parallelogram has a special name, which is called a rectangle. Okay. Item 13, F and G. So F and G. Well, we talked about the fact that G and B are both parallelograms, but this one's not. This one does not have all 4 sides parallel to each other. They can't be 2 parallelograms. There can't be two rhombuses, and they're not two trapezoids, so they must be quadrilaterals. And quadrilateral simply means a shape that has four sides. So both of these shapes do have four sides. They're not parallelograms, they're not rhombuses, and they're not trapezoids. 14, how many lines of symmetry on L? L is here. One line of symmetry down the middle. Another line of symmetry here. So that means that when you fold it over, like if you were to cut it out and fold it over, it'd be one fold there and a second fold there, and that's it. So item 14 has two lines of symmetry. Item E, same thing. Imagine you cut it out on paper and then fold it over. I could only fold it up across here to have symmetry, just one line. 16, item I is a square. Again, imagine that you cut it out and you fold it in paper. I could fold it down that way. That'd be one fold. Open it back up, fold it this way. Second fold where both sides line up exactly. The third fold will be across there, and the fourth fold would be there. So this one has four lines of symmetry. Four lines of symmetry. Number 17, C is an equilateral triangle. There it is. And that means that all sides are the same. So I can fold it down the middle. Again, imagine you cut it out of paper. You fold it down right down the middle that way. That's one line of symmetry. But then I could also do it this way. That's two lines of symmetry. I can also do it this way. Three. So a equilateral triangle has three lines of symmetry. And number 18, item K has how many lines of symmetry? We talked about item K being a scalene triangle, and scalene triangles, sorry, my computer's being laggy. Scalene triangles have no lines of symmetry. That's why they are scalene. They have no sides that are the same. That means there's no place you can fold them that they'll ever fold on top of each other equally. All right, number 19. Come on, computer. You can do this. Come on. Come on. Sorry. Very laggy right now. Okay. So, true or false, some trapezoids are rectangle. That's false. We talked about that before. Some parallelograms are rectangles, or rectangles are parallelograms, but not trapezoids. Trapezoids have only one side of parallel line. The other ones are not, so they can't be rectangles. That's false. And true or false, a rectangle is also a parallelogram. We talked about that. That is true, because a rectangle has opposite sides that are parallel, and so is a parallelogram. That's true. Okay, so that was the walkthrough for DLM-043, the quiz. And use what you learned here to take the test, which is DLM-045. Hope you learned something, and thank you for learning with Mr. C.